Good day, future RMTs. Welcome to our online discussion. And in today's lecture, what I'm going to discuss is all about aldehydes and ketones. Our learning outcomes are as follows. Number one is to name aldehyde and ketones. Number two is to discuss the physical and physical and chemical properties of aldehyde and ketones. And lastly, to predict the products of aldehydes and ketones. To start with, I would like to inform you and I would like to know that these organic compounds, aldehydes and ketones, are the organic compounds that contains our carbonyl group. As you still remember, in our discussion in the introduction to organic chemistry, we said that carbonyl group is a carbon having a double bond with oxygen. Okay? So the last time that we have discussed, or the last topic that we have discussed, is all about uh, carbon having a hydroxyl group, carbon having a uh, bond with amino group, okay, carbon having a bond with sulfide or disulfide, and carbon having a bond with an oxygen, okay, or the ether. Now, this point in time, we have our carbonyl group. Again, when we said carbonyl group, our carbon is having a double bond with our oxygen. Okay, and later we're going to discuss what is the properties of our carbonyl group. But for this time, what we're going to discuss, or what we're going to give an emphasis, is how are we going to differentiate aldehydes and ketones, since both of them have the carbonyl group on the long chain of the carbon. Okay, remember guys, when we said an aldehyde, this is a organic compound wherein the carbonyl group, okay, wherein the carbonyl group are bonded to a hydrogen atom. Okay, usually the carbonyl group is bonded to another carbon. Okay, to another carbon and a hydrogen group. Okay, and most of the times our aldehyde group is attached, to the terminal carbon. Okay, most of the times our aldehyde is, or the carbonyl group in aldehyde is attached or located at the terminal side of the parent chain. Now, for our ketones, it is also an organic compound that contains our carbonyl group. Just so happen that the carbonyl group of our ketones is on the middle of the chain, or as we define it, this is a organic compound, or the compound that contains a carbonyl group wherein the carbonyl group is attached to two other carbons. That's why we said that ketones, having a carbonyl group, can be seen on the middle chain of the carbons because it is in between two carbon groups or two methyl groups. Okay. Now, how are we going to name our alkanes? Okay. Remember, the first thing to do and the first thing to remember is to look for the longest chain of carbon. Look for the parent chain. Okay. And you have to take note and you have to remember that you should start on the carbonyl group. Okay. Since that is our functional group in this case. You have to make sure that the longest chain of the carbon contains our functional group, and that is no other than our carbonyl group. As we defined in the previous slide, we said that aldehyde is usually, okay, on the terminal side of the chain. Therefore, in order for you to look for the longest chain of the carbon, the first thing to do is to look where is our functional group, and after that, you have to take note, okay, and you have to count and then identify where is the longest chain of carbon. If you still remember the way how you name alcohol, you omit the final E of the parent alkane and you change it to OH in alcohol, or OL rather, OL. This time, that's basically the same thing. Just so happen that instead of OL, we are going to use AL, okay, to indicate that is our aldehyde. Now, in alcohol, there's a need. In amines, there's a need, to indicate the number of our functional group, or to locate the location, or to locate the carbon where the functional group is attached. In aldehyde, it's the other way around. Since the functional group of aldehydes is at the terminal chain or terminal side of the carbon, there is no need for us to identify, indicate the number of the location because it is understood and it's clear that the carbon that bears our aldehyde or the functional group is already the carbon number 1. Okay? Now, how about if you are going to name unsaturated? When we said unsaturated, it contains a double bond. Okay, that's basically the same thing, no? It just so happened that you have to use the suffix enal. Enal. E-N-A-L. Enal means there is a presence of a carbon-carbon double bond. However, if you still remember our discussion in alkenes and alkynes, you have to indicate the location of where the double bond is. In this time, if you were given unsaturated hydrocarbons, okay, you are about to give the location of your carbon-carbon double bonds, not of the location of your aldehydes. I repeat, the location that you are going to include is the location of your carbon double bonds, not the location of our aldehyde or carbonyl, because it's pretty clear that there is no need to indicate the presence of our functional group. Alright, so numbering, the number or carbon chain begins with the aldehyde, and that's still our point of reference because that's the functional group. Aldehyde is superior than our alkene. Okay? How about for aromatic? Okay, for aromatic hydrocarbons, that's basically the same thing. Okay, let's say for example this one. We have here your trans-3-phenyl 2-propanol. Okay, which is also known as the cinnamaldehyde. Why trans-3-phenyl? Okay, so this is our carbon 1, carbon 2, carbon 3. On carbon 3, we have there your phenyl group. On carbon 2, we have the double bond. Why trans? Okay, we have here the oxygen. We have here the oxygen. On the opposite side, we have there. That's why it's trans. This one is your benzaldehyde. If you still remember in our discussion about the benzene ring, no, this is our benzene ring plus an aldehyde group here. Okay, instead of saying benzenal, no, it's incorrect. No, it's proper to say benzaldehyde. And this is the odor, no, that can be found in the alcohols. Vanillin is a phenol. This is also a ether, and at the same time considered as a aldehyde. This is the aldehyde group, this is the ether group, and this is our hydroxyl group, phenol in other words. Okay? Instead of saying that this is our 4-hydroxy 3-methoxy benzaldehyde, it will be better to say as it's a vanillin since it is a common name. However, the one that I've said a while ago, 4-hydroxy 3-methoxy, okay, benzaldehyde is considered as the IUPAC name. Now let's have an example. Okay, how are we going to name these organic compounds? Okay, the first organic compound we have here your carbon 1. This is our carbon 1. Why? Okay, that is our carbon 1 because that is our carbon that contains the functional group. So this is carbon 1, no? Carbon 2, 3, 4. 1, 2, 3, 4, 5. Therefore, this is our long chain of carbon. Okay? This is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. That is pentane. Okay? Omit the final E, that will becomes pentanal. Okay? Penta. Okay? Pentanal. Now, we have attachment on carbon number 2 and carbon number 3. Ethyl. This is methyl. Okay? Therefore, that will be 2-ethyl, 3-methyl, and then pentanal. Take note, this should be a one word. Pentanal. Okay? So this structure is our 2-ethyl, 3-methyl, pentanal. How about the next structure? Okay? So we have this, our benzene ring, right? Okay, so we have here our C double bond O H, and that is how it looks like. And then we have here an ethyl group. Okay, so again, this is our carbon 1, carbon number 2, 2-ethyl, okay, benzaldehyde. Next is we have like this. Okay, this is carbon 1, carbon 2, carbon 3, carbon 4, or 3, 4, 3, 4. So we have 3, 3, dimethyl butanal. And the last one is we have, okay, so let me erase everything first before I name the last. Okay, so I will draw it. Let me see it first on a bigger aspect. So that will be carbon 1, carbon 2, right? Carbon 3, carbon 4, 5, 6, 7, 8. So if we are going to make it a simple structure, that will be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have here our hydrogen. We have here our oxygen. 1, 2. We have a double bond here. And then on carbon number 4, we have methyl. 1, 2, 3, 4. So it's basically like this. So that will be 4-methyl rather. 4-methyl oct dash 2 dash enal. Or you can say that this is 4-methyl dash 2 dash octenal. Basically, they are just the same. No? Either of the two is accepted. Okay, so that's how we name our aldehydes. Next, how about our ketones? Again, remember, for ketones, no, that's basically the same thing. We just have to add, or we just have to use the suffix one. Okay, one. So the first structure that we have is Okay, double bond O, carbon 1, 2, 3. This is our 2-propanone. Okay, that is our 2-propanone. The other one is we have 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We have here an attachment. Okay, so what will be the name of this organic compound? Okay, we're going to start. We're going to start here. 1, 2, 3, 4, 5, 6. Why not here? 1, 2, 3, 4. We'll have 4 as our parent. Our target is to give the lowest set of number. Therefore, instead of 4, now we should have 3. Okay, so that will be 5-methyl 3-hexanone. Okay, 3-hexanone or 5-methyl, okay, hexan 3 on. But it will be better if we will write this way. We will only use this one if there are other attachments, if there are other functional groups, no, that is somehow inferior than our ketones. Okay, later. Okay, next in line is we have this one, our cyclo. Oh my god, I'm sorry. I thought I am having my. I'm sorry, guys. Okay, and then CH3. Okay, so we have this one. This is our 1-phenyl. No. This is our 2-methyl 1, 2, 2-methyl cyclohexanone. Now take note, guys, in cyclohexyl or in cyclic form, again, the functional group is the 1 or the carbon number 1. Okay, so the next one is this. Okay, so this should be our carbon number 1, carbon number 2, carbon number 3, and carbon number 4. So you have a double bond on carbon number 3, and we have our carbonyl group on carbon number 2. So that will be 3-butene, okay, 3-butene 2-on. 3-butene 2-on. Alright. Now, next, how about the last one? Okay, so we have there our phenyl group. So how are we going to name this? This is now our carbon 1, carbon 2, and carbon 3. Okay, so this is 1-phenyl, 1-propanone. Okay, this is now our 1-phenyl, 1-propanol. Now take note, guys, no, remember the parent name of the alkane, no, look for the longest chain of the carbon and then name it as the parent alkane. Omit the final E, no, or omit the final ANE pala, okay? Omit the final ANE, of the parent alkane, and change it to ONE. Okay? Next, in aldehydes, there's no need to give the name. There's no need to indicate the name. However, in ketones, number the chain from the direction that gives the carbonyl group the smallest possible number. Okay, we have to indicate our location in carbonyl since it is on the middle chain. Okay, now for our unsaturated hydrocarbons, that's basically the same thing. no, give the IUPAC names for unsaturated ketones are made by changing the final ANE to, okay, the final ANE, okay, kapag unsaturated, kapag saturated is ONE, no? This is saturated. Now, how about unsaturated? Unsaturated will be named as E, no, ENONE, enone, okay, enone, enone, okay. So please take note of that. Okay, that's how we name our ketones. Okay, that is how we name our ketones. Now, how about the aldehyde that contains, or aldehydes or ketones that contains our hydroxyl group and our amino group? Again, take note that aldehydes and ketones are superior than alcohol and our amino group. Therefore, if there are hydroxyl group or amino groups present in our long chain of carbon, that should be, or that will be named as our substituents or constituents, no, aside from being named as the parent organic compound. Therefore, let's say for example this one, we have here your carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. We have here a hydroxyl group, no, on carbon number 3. Okay, that will be, and on carbon number 4 we have a metal group. Again, hydroxyl group is inferior than our aldehydes or carbonyl group. Therefore, this will be our parent chain. Our parent, no? Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, 3-hydroxy, 4-methyl pentanal. It's basically the same thing for ketones, no? Since carbonyl is higher than amino and hydroxyl. So carbon 1, carbon 2, 3, 4, 5, and 6. So we have 3 amino, 4 ethyl, okay, and 2 hexanone. Okay, why 2 hexanone? We have on carbon number 2, we have there our ketone. Okay, now how about for our common names? Now take note of this. For the common names of aldehydes, it's basically derived from the corresponding names of the carboxylic acid or common names of the carboxylic acid. Let's say for example, okay, take note guys. Let's say for example, for our methanol. So let me write. No? Let's say for example, methanol. Okay, this is our methanol. Methanol. Okay, if we will derive, no, the carboxylic acid, that will be this way. No? 1, 2, 3, 4. This is your methanoic acid. Okay. And the common name of methanoic acid is formic acid. Okay. Formic acid. Now take note, I've said that the common name of our aldehydes is derived from the common name of our carboxylic acid. We are just going to remove the ic acid and change it into aldehyde. Therefore, the common name of methanol is your form as in kasi as in ic acid, and then add the word aldehyde, formaldehyde. Okay. Another example is we have here your this is our ethanol, no? And the opposite of that, or the carboxylic acid of ethanol is ethanoic acid. Common name of this is your acetic acid. right? CH3, COOH, no? Again, remove the ic acid. That will be your acetaldehyde. Okay. For butanal, that is our butanoic acid, no? And the corresponding common name of butanoic acid is your butyric acid. Okay, remove the ic acid. That will be our butyraldehyde. No? Yun yung hindi ka masama. Okay? Kasi mabutyraldehyde ka. Ay, walang kwentang joke. Hindi sila tumawa. Okay? So, that is our butyraldehyde. Okay? Now, let's say for example, another one is hexanal. Okay, having 6. The corresponding common name of hexanal or the corresponding carboxylic acid of hexanal is the hexanoic acid. And the common name of hexanoic acid is caproic acid. Again, remove the oic acid, ic acid. That will be our caproaldehyde. Okay, so that's the way. How are we going to name our or give the common names of our aldehydes? Again, it is derived from the common name of our carboxylic acid. Now, how about for ketones? For ketones, now name each alkyl group or aryl group that is bonded to the carbonyl group and then arrange it into a increasing molecular weight. Let's say for example, okay, I'm going to draw 2-butanone. I'm sorry. Okay, 2-butanone. 1, 2, 3, 4. Okay, this is our 2-butanone. Again, ang sabi, name the alkyl group or aryl group no bonded to carbonyl group. So this is our carbonyl group. Okay, this is our carbonyl group. Right? Now, ang sabi, name the alkyl group. So we have here 1 carbon. This is our methyl. 1, 2, 2 carbon, ethyl. Okay, ang sabi, arrange no, in increasing order of molecular weight. So, we have here your methyl, ethyl with space, methyl space, ethyl space, ketone, or most commonly known as the MEK. Okay? Most commonly known as the MEK, methyl ethyl ketone. Alright, another example is that 3-methyl, 3-pentanone. So we have 5. 1, 2, 3, 4, 5. Okay? This should be 2-methyl pala. This should be 2-methyl. Okay. 2-methyl, 3-pentanone. So 1, 2, 3, double bond. And we have here our methyl group. Okay? So 1, 2, ethyl. 1, 2, this is ethyl. Again, Y shape, that is your isopropyl. Then arrange this in an increasing order. That will be our ethyl, space, isopropyl, space, ketone. And that is the common name. Okay. Last example, before we proceed to our physical properties. Okay. Example is we have 2-hexanone. Okay, 2-hexanone. Okay. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. On carbon number 2, we have there our carbonyl group. Okay, so this is our carbonyl. Then name this. This is methyl. 1, 2, 3, 4. This is butyl. Right? 1, 2, 3, 4. Okay, so this is now our methyl butyl ketone. Okay, methyl butyl ketone. Alright, so that is how we name our aldehydes and ketones, or that's how we give the common name of our aldehydes and ketones. Alright, at this point in time, we are going to discuss the physical properties of our aldehydes and ketones. Take note, guys, that the difference between the carbon and the oxygen double bond gives you an electronegativity that falls under the category of a polar covalent bonds. Carbon is partially positive charge and our oxygen is partially negative charge. That's why no, that's why we said that this is a polar covalent bonds. However, no, this is not capable of forming a hydrogen bond because of the partial positive charge and the partial negative charge in our oxygen. Now, I have here points to remember, and I want you to take note these properties every now and then. Remember that liquid aldehydes and ketones, they are weak, there are weak intramolecular attraction between the partial positive charge on the carbonyl carbon of one molecule and the partial negative charge on the carbonyl oxygen of another molecule. That's why it is not capable of forming a bonds because of the weak intramolecular structures, again because of the partial positive charge on the carbon or carbonyl carbon and of the negative charge of the carbonyl oxygen. Next, no hydrogen bonding is possible. This is what I've said a while ago. No hydrogen bonding is possible between aldehyde or ketone molecules because they have no polar OH or NH. However, they are considered polar because of the electronegativity difference or the difference of the electronegativity between carbon and oxygen. But since it has no OH or NH, it is not capable of forming a hydrogen bonding. Take note, people, that aldehydes and ketones have lower boiling points than alcohols and carboxylic acid, compounds in which there is a hydrogen bonding between molecules. Tama naman, di ba? That there is a bonding of hydrogen bonding between alcohol and carboxylic acid, but in aldehydes or ketones, it is not possible. All right. Okay. So we have here the summary of our boiling points. No, diethyl ether, we have pentane, butanal, butanone, butanol, and propanoic acid. These are our carbons or organic compound of the same molecular weight. And we can say that carboxylic acid has the highest boiling point. Butanol has a lower, or butanol, or even uh, 2-butanone, no, that contains our carbonyl group, okay, will have a lower boiling point as compared to alcohol and propanoic acid or carboxylic acid of the same molecular weight. Di ba? Yun yung sinabi natin kanina. Aldehydes and ketones has a lower boiling point, no, as compared to alcohol and carboxylic acid. And this alcohol and carboxylic acid is what we call capable of forming a hydrogen bonding because of its OH bond or OH carbon on the functional group. Now remember guys, no, take note that formaldehyde or the methanol, acetaldehyde or the uh, ethanol, and acetone. Take note nga pala, before I forgot, acetone is the simplest ketone that we could have. Okay? The simplest ketone. Methanol is the simplest aldehyde. Okay? Again, remember that formaldehyde, okay, acetaldehyde, and our acetone are infinitely soluble in water. Okay? Remember that aldehydes and ketones are less soluble in water as the hydrogen portion of the molecules increases in the size. Okay? Even though that they are polar, no, as they become more or increase their molecular weight, nababa din po yung kanilang solubility, becomes less soluble in water. Okay, now what are the important reactions of our carboxylic acid, of our aldehydes? If you still remember the oxidation of a primary alcohol, we said that the oxidation of the primary alcohol upon exposure to our oxidizing agent, potassium dichromate, no, will give you an aldehyde. If you still remember that, well, I hope you still remember that. And I've said that the further oxidation of our aldehyde will give us our carboxylic acid. Okay, take note that this strong oxidizing agent in the presence of our sulfuric acid as a catalyst will give us our hexanoic acid, will give us our carboxylic acid. Okay, so again, remember that the oxidation of our aldehyde in the presence of our strong oxidizing agent, for example, we have here your potassium dichromate, in the presence of sulfuric acid, will give us our carboxylic acid. Okay, so this is 1, 2, 3, 4, 5, 6. Hexanal, okay, oxidized aldehyde, 1, 2, 3, 4, 5, 6. Hexanoic acid. Ano yung nangyari sa oxidation? Nagkameron po siya ng gain of what we call oxygen. Now remember guys that liquid aldehydes are easily oxidized or are sensitive, no, in the presence of oxygen. And our aldehydes, or our liquid aldehydes in particular, if they are exposed in oxygen, it will easily convert, no, to a carboxylic acid. Again, liquid aldehydes are sensitive in oxygen. Okay, that's why it must be protected from oxygen during storage or even during laboratory experiments. That's why I get angry and mad every time that my students will use benzaldehyde and they will expose it in air. Exposure of benzaldehyde, a liquid aldehyde, will rapidly oxidize, no, in the presence of oxygen, will rapidly oxidize into benzoic acid. So hindi na siya sa benzaldehyde, si benzoic acid na siya. So please take note of that. Okay, if you will perform na your laboratory activities in MLS 103, make sure that if you are going to handle benzaldehyde, you will not expose it into air, because exposure of our benzaldehyde, or exposure, or in general, exposure of our liquid aldehydes will rapidly oxidize to carboxylic acid. Okay, because they are sensitive to the oxidation of our oxygen. Okay, now how about for the oxidation of ketones? Remember guys that ketones resist oxidation by simply using our potassium dichromate. Okay, remember, oxidation of ketones using your potassium dichromate is impossible. Okay, now tolerance reagent, we have here a tolerance reagent. A tolerance reagent is specific for the oxidation of aldehydes. Okay? In other words, oxidation of ketones is not possible. Okay? Oxidation of ketones is not possible. Okay, so a tolerance reagent is used to differentiate our aldehydes from ketones. No? Because tolerance reagent is specific for the oxidation of aldehydes. Now, if done properly, there will be a silver deposits, and these silver deposits will be is used on the walls of the containers and will serve as the silver mirror. Okay, that's why if you are going to perform tolerance test no, for ketones, okay, ibig sabihin, kapag po nagkameron ng formation of silver deposits, that is not a ketone but rather a aldehyde. Okay? Because tolerance reagent is specific for the oxidation of aldehyde. Again, there is a silver mirror deposit or silver deposits, no, almost similar dun po sa likod ng salamin. As you can see in this illustration, it's like that. Well, I hope that you were able to discuss this in laboratory. Now, another type of reaction of our aldehydes and ketones is its ability for the reduction. Okay? Remember, in our discussion of our alcohol, primary alcohol once oxidized, no, will give you aldehyde. Okay? Secondary alcohol once oxidized will give you ketone. This is the other way around in reduction. In the reduction of our aldehyde, in the presence of metal transition or transition metal catalyst, will give you a primary alcohol. And reduction of secondary of reduction of our ketone will give us our oxygen. I will give us our secondary alcohol. So basically, niloloko ka lang ni organic chemistry. Pinaiikot-ikot ka lang niya, kagaya ng pagpaikot-ikot sa'yo ng crush mo at ng boyfriend or girlfriend mo. So ganun lang din yung mga reaction dito sa organic chemistry. Umiikot lang siya. Kaya hindi mo siya dapat kalimutan. Yun nga nagpaikot sa'yo at nanloko sa'yo, hindi mo nakalimutan. Ito pa kayang reaction ng organic chemistry. Again, remember, oxidation of a primary alcohol will give us an aldehyde. Further oxidation of aldehyde in the presence of a strong oxidizing agent will give us carboxylic acid. Therefore, reduction of carboxylic acid will give you an aldehyde. Reduction of aldehyde will give you a alcohol, primary alcohol. Reduction of an alcohol will give you an alkene. Reduction of alkene will give you an alkane. Bumabalik ka lang dun sa dati. At sana natatandaan mo at hindi mo siya nalilimutan. Next, reduction of ketone will give us a secondary alcohol. Reduction of alcohol will give us an alkene. Reduction of alkene will give us a alkane. Umuulit ka lang, bumabalik ka lang. Alkane plus water, walang reaction. No? Alkene plus water, wala ding reaction. But if you will put sulfuric acid, a strong acid, a acid catalyst, there will be a reaction. And the product is alcohol. Si alcohol na-categorize as primary, secondary, tertiary. Primary alcohol, oxidation, aldehyde. Oxidation of aldehyde, carboxylic acid. Reduction of carboxylic acid will give you an aldehyde. Reduction of aldehyde will give you an alcohol rather. Reduction of alcohol will give you an alkene. Reduction of alkene will give you an alkane. Umiikot ka lang sa kamay ni organic chemistry. Kaya wag mo siyang kalimutan at tandaan mo. Okay? Now, how about for the reduction using sodium borohydride? Take note, guys, that's the most common reagent in the reduction of aldehydes and ketones. What I have shown you a while ago is a reduction of aldehydes and ketones in the presence of your transition metal catalyst. Most of the reduction reaction of our aldehydes and ketones use our sodium borohydride as its reduction or reducing agent. Okay? Take note that our sodium borohydride contains a hydrogen ion, hydride ion. Hydride ion is different from hydrogen ion. No, hydride ion contains 2 electrons. No, it has 2 electrons or 2 valence electrons and bears a partial negative charge or a negative charge. In the reduction of sodium borohydride, hydride ion adds partially positive carbonyl group which leaves a negative charge on the carbonyl oxygen. Okay, and the reaction, reaction of this intermediate with aqueous acid gives us our alcohol. Okay, now remember that the most common reaction, or this is the reaction or the what happened in the reaction. Okay, so again, the product of this one is an alcohol. As you can see here, our hydride ion attaches to the carbon, leaving our oxygen with a partial negative charge. Why? Okay? Nawalan po ng carbon double bond. Nawalan po ng sineshare ng isang electron yung carbon natin sa oxygen because of the electrons being shared by our hydride ion. Therefore, our carbon will form a 4 hydrogen bonds, alkoxide ion. The initial carbon double bond will split into carbon single bond. Therefore, our oxygen here will have a negative charge because it needs 1 more electrons. Okay, the electrons that will be shared to this oxygen will be coming from our water. Will be coming from our hydronium ion. Will be coming from the hydronium ion. Okay, will be coming from the hydronium ion. Since this is not stable because it has an excess hydrogen, okay, the hydrogen or the electrons being shared by this hydrogen or the excess hydrogen in the hydronium ion will be paired to our alkoxide ion since our oxygen here has a partial negative charge because of the insufficiency in the electrons. Electrophile siya. So, kailangan siyang madagdagan ng another electrons. Okay? Which will give us a carbon hydroxyl group or OH bond. Example, for this one, we have here our ketone. Mawawala po yung double bond natin, will split because of the hydrogen being given by this sodium borohydride. Okay? Magkakameron po tayo dito ng mawawala po yung double bond natin dito, magkakameron tayo ng hydrogen. Remember that reduction is a acceptance of hydrogen. Okay? Therefore, our oxygen having a double bond initially will have an deficiency or mababang number of electrons on its valence shell. That's why it will require additional electrons, and these electrons will be coming from our hydronium ion. Since hydronium ion naman has an excess hydrogen on its valence shell or electrons on its valence shell, no, the hydrogen of your hydronium ion will be transferred to this alkoxide ions. Therefore, it will form a OH bond, and this is now your cyclohexanol. Okay, that's basically the same thing here in the cinnamaldehyde in the reaction of our cinnamaldehyde. Okay, there will be a reaction or there will be a gain of our hydrogen. That's why our carbon double bond will lose. No, will have a lose in our double bond. Mawawalan ng electron isa, si oxygen. Magkakameron naman ng hydrogen na another attachment kay carbon. Since magkakameron to ng partial negative charge, magiging alkoxide ion, yung pong hydrogen, no, na nanggagaling sa o nanggaling dito sa water in this case will be bonded to this oxygen so that it will form a alcohol, and this is your cinnamal or cinnamyl alcohol. Okay, the most common reaction of our reduction reaction in the presence of our carboxylic or in the presence of our carbon double bond or carbonyl, no, in the biological system is the reduction of nicotidamine adenine dinucleotide or abbreviated as the NADH. Now remember guys, know that the pyruvate is a product. Okay, pyruvate is a product of a glycolysis or breakdown of our glucose, and pyruvate, in addition to your nicotidamine adenine diphosphate or dinucleotide rather NADH, no, will have, magkakameron po tayo dito. Okay, magkakameron po tayo dito ng transfer of our hydrogen, no. Magkakameron po tayo dito ng transfer of hydrogen from NADH. Ibig sabihin, the carbon double bond of pyruvate will be splitted into carbon single bond. Therefore, this oxygen will have a less number of electrons. That's why it carries a negative charge. And the water or the hydrogen from the hydronium ion, since it has an excess hydrogen, will be attached to your OH to give us our lactate. Okay, again, take note, no, that the level of our lactate is inversely proportional to the level of our glucose. As the glucose level decreases, the level of our lactate increases. Why? Bakit nag-increase ang level of lactate if the glucose level decreases? Again, remember that the product of our breakdown of the glucose is pyruvate, and pyruvate will react not with our nicotidamine adenine dinucleotide having the reduction reaction, which will give you your lactate as the end product of this metabolism. So habang minametabolize, habang nauubos ang glucose level, tumataas naman ang lactate. That's actually the same thing, the same principle kung bakit sa kung bakit sa CSF ng tao. CSF stands for cerebrospinal fluid. Okay, let's say for example, one of the most common condition that includes the infection of our CSF is the meningitis. In bacterial meningitis, since the bacteria will utilize the glucose present in the CSF, because the glucose level in the CSF is roughly 60 to 70% of the total serum or plasma glucose. Okay, the glucose level of a patient, or the CSF glucose level of a patient with bacterial meningitis is deficient or decreased because the microorganism present or the bacteria that is present in the CSF will utilize the glucose as its sole source of energy. Having said that the glucose is being metabolized by the bacteria, no, there is an increased level of the lactate, which is the end product or the end product, no, of our glucose metabolism. Kasi nga, by the way, actually the end product is pyruvate, pero yung pyruvate ay nare-reduce into a lactate. So that's the most common application of this type of reaction, no. Akala mo sa test tube mo lang siya nakikita in vitro, but that's actually also what is happening inside the human body. That's why it is important for you at this point in time to remember and understand the concepts of organic chemistry. Okay? alcohol plus our plus our aldehyde will give you what we call the hemiacetal. Take note that the addition of a molecule of alcohol to a carbonyl group will give you an aldehyde or ketone, or will give you, the addition of alcohol to the carbonyl group of aldehyde and ketone will give you a hemiacetal or a half acetal. Okay? Ano po yung mangyayari doon? Yung alcohol natin, no? Yung alcohol natin, okay, yung hydrogen mas split. Okay? Yung alcohol natin maglo-lose ng hydrogen. Yung ating aldehyde, mawawala po yung ating carbon double bond with oxygen. Bakit? Because carbon will have a bonding to another oxygen from the alcohol. Si alcohol nag-lose ng hydrogen, hydrogen will attach to the carbon that carries a negative charge once that the double bond splitted. Okay? The functional group of hemiacetal is a carbon bonded to one OH and OR group. This is our OR group, and this is our OH group. Actually, this is a ether. This is an alcohol, and that is what we call hemiacetal. Remember, in forming the hemiacetal, the hydrogen of the alcohol adds to the carbonyl, no, and the OR adds to the carbon or carbonyl. Okay, so this is actually what is another type of reaction. Take note, guys, that hemiacetals are generally unstable and the only minor components of an equilibrium mixture except in one or more important type of molecule. Now, remember that in a hydroxyl group when a hydroxyl group is a part of the same molecule that contains the carbonyl group, 5 or 6-membered ring can form. Okay? And the compound exists almost entirely a cyclic hemiacetal form. Okay? Remember that a hemiacetal reaction is a reversible reaction. No? This is a reversible reaction. Again, take note. Okay, this is a reversible reaction. Makinig. This is our aldehyde. This is our alcohol. This is the addition of alcohol. Yung addition of alcohol natin, again, take note ha, makinig po mabuti. Yung addition of alcohol po natin, no, sa hemiacetal natin, okay, ay pwedeng mabalik sa acetal. Ano pong ibig sabihin nun? There is a complete, no, reaction. Take note. Ethanol, an alcohol, no, will lose hydrogen. This hemiacetal will lose hydrogen. No, the OR group, this is the OR group of our ethanol, will attach to this one. No, I'm sorry, the methyl group or the alkyl group, the alkyl group of our alcohol will attach to the oxygen, forming another hemiacetal. Now, this time, hindi na siya half. Hindi na siya half kasi dalawa na yung ating acetal form. That's why, ang tawag na sa kanya, unacetal. Yung pong ating OH na nawala sa alcohol, ma-attach sa kanya yung ating hydrogen na nawala sa oxygen, giving us a water. Again, this is a reversible reaction. Ibig sabihin, an acetal plus water will give you an alcohol and a hemiacetal. Another example, we have here a hemiacetal. Pasimplihin na lang natin para hindi tayo masyadong mahirapan. Babalik po ako dito sa previous slide para ma-relate at hindi po masyadong malito ang mga bata. Again, yung addition of alcohol to our aldehyde or to our ketone will form a hemiacetal. Hemiacetal means half acetal. Okay? Our alcohol, in this case, will lose our hydrogen. Our aldehyde will lose, sige na nga, I will write. I hope that if I write, you can follow. Okay? So this is the hemiacetal reaction. Take note guys, originally, our aldehyde, ang gagawin ni alcohol, lose, lose hydrogen. Ang gagawin ni aldehyde, okay, split the carbon double bond. Okay, two carbon single bond having oxygen a partial negative charge. Okay, so what will happen is like this. Okay, nagkameron din ng negative charge kay hydrogen, kay carbon. Kasi nawalan siya ng electron na sineshare kay oxygen. So, ano mangyayari? Again, nung ating alcohol maglulus ng hydrogen, what will happen is like this. Meron ding negative charge ang ating oxygen dito. This one will be bonded to carbon kasi positive charge. Nucleophile to electrophile. So this one will be bonded to this one. Okay? Dito siya ma-attach. And once na-attach siya dyan, what will happen is the formation of our OCH2 CH3. Sino ang nawala dito? Hydrogen. Sino nawala kay alcohol? Si hydrogen. Saan siya mapupunta? Kay OH. This is now, guys, okay, our hemiacetal. Okay? This is now, guys, our hemiacetal. When we said hemiacetal, this is your half acetal. Okay? This is your half acetal. Now, what if our hemiacetal will have another reaction with our alcohol? So, ganito naman po yung nangyayari. Please take note that the addition of our alcohol to hemiacetal is a reversible reaction. Bakit po siya naging reversible reaction? Okay. We have our hemiacetal aldehyde. Plus alcohol. Okay? Plus alcohol. Ano po yung mangyayari? Again, ang mechanism ni alcohol, lose hydroxyl group. Okay? Mechanism of our hemiacetal, lose hydrogen. Kung nag-lose siya ng hydrogen dito sa OH niya, okay? Kung nag-lose siya ng hydrogen sa OH niya at nag-lose ng OH sa alcohol, ano yung mangyayari? Water. Okay? Dito nagkaroon ng negative charge. Dito nagkaroon ng positive charge. Nawalan siya ng electrons na sinishare ng OH. Dito nawalan siya ng electrons na sinishare ng hydrogen. Again, nucleophile to electrophile. Ano po yung mafo-form natin? This time, we have here your acetal. This is now your acetal. Now, why is this a reversible reaction? Acetal plus water, what will happen? Water will split into OH and to your hydrogen ion. Okay? OH2, hydrogen ion. Lose this one, pasok to dito, ito at saka ito to give you alcohol and your half acetal or hemi-acetal. Okay? So that is what we call the addition of alcohol to hemi-acetal. I hope you understand. Don't worry. We'll have that questions will be entertained in our synchronous session. Okay? So, ito po yung nangyayari naman. No? So, this is just the mechanism of the formation. No, there is step 1 is the addition of a proton. Step 2 is the reaction of electrophile and nucleophile. Step 3 is the proton transfer from another oxygen. Step 4 is the breakdown from one stable molecules or ions. Step 5 is the reaction of electrophile and nucleophile to form a new covalent bond. Step 6, take away the proton. Okay, and those are the steps. Now, those are the steps in what we call the formation of acetal. Okay, now we have what we call ketoenol tautorism. Okay, a carbon atom adjacent to carbon double bond is called an alpha carbon, and the hydrogen now bonded to it is what we call our alpha hydrogen. The carbon next to the carbonyl group is termed as the alpha carbons, and the hydrogen attached to the alpha carbons is termed as the alpha hydrogen. Okay? So, ano po yung meron dito sa ketoenol tautorism? An aldehyde or ketone that has a hydrogen on a carbon or on the alpha carbon, I repeat, the hydrogen, or an aldehyde or ketone that has a hydrogen on a carbon is in equilibrium with a constitutional isomer called enol. Enol. Okay? The name enol is derived from the IUPAC designation of both alkene and an alcohol. Okay? In ketoenol, the keto form generally predominates. Example, we have a acetone which is in the ketone form. Kapag po itong oxygen na ito, again, nawalan po tayo ng carbon double bond, mag-attach sa kanya si hydrogen. And the carbon, will have a double bond with this one. So, sige, sulat po natin. So this is how it looks like. Okay. Sige. Gawin nating structural. Okay. This is the ketone form, keto form. So, ano mangyayari? Maglulus siya ng high, sige. Okay, maglulus, itong carbon na to, maglulus po siya ng hydrogen. Okay? Yung carbon initially having double bond, no, mawawala po yung double bond. Magiging negative charge, nag-lose siya ng hydrogen. Dito mapupunta si oxygen. Magkakameron po tayo ng double bond here. And this is now our acetone in keto form. Ketoenol. Okay? That is our acetone in ketoenol form. Okay, let's try. Please try to answer this one. Okay? Please try to answer that one. What will be the product, okay, of this reaction? Please try before I give the correct answer. Okay? So again, ano po, ayan, I'm sorry. So we have our ketone. This is our 2-methyl cyclopropanone. Cyclohexanone. Cyclohexanone. Hexanone. Ano ba yan, Mark? Okay, so we have the reaction. So, ano po mangyayari? It's basically the same. That's basically this thing. So, we have our carbon, OH. Okay, pwedeng dito ang double bond. Or, this way. Or like this. OH. Or dito ang double bond. That's the product. Okay, or this one. 1, 2, 3, 4, 5. Number 2, pentanone. So, the product will be like this. 1, 2, 3, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So, we have OH, double bond, or like this, OH, double bond. Okay? And that is our product. Okay, so that is how we get our ketoenol tautorism. Okay? Nawawala yung carbon double bond, nagkakaroon ng double bond with carbon and carbon. Okay, now identify the functional groups. Let's say for example in this one, cortisone. So we have here ketone, alkene, another ketone. This is a ketone also, hydroxyl group, no? Aldehyde. And this is an aldehyde. Aldehyde, ketone, aldehyde, uh, ketone. And this is also a alkene. Okay, so those are the functional groups present. Oh, we have here alcohol. Okay, so those are the functional groups present in these hormones. Okay, so thank you, and I hope you learn and will discuss or will have our reinforcement on the specified date. So once again, thank you and God bless you all.